Okay, we have our another integral. This one's from the UK integration bee sample problem number 10. We have the integral from -2 to 2 of x cubed cosine x over 2 plus 1/2 times the square root of 4 minus x squared dx. Okay, my first thought on this one was that we actually could use odd functions. Notice that we have symmetric bounds here around 0, right? And we have this principle, if we have an integral like minus a to a, and if f of x is an odd function, then we could say the whole integral is 0. So what we need to do here is we just need to show, if we can show that this whole thing, if we can show that's odd, then our integral is 0. And our definition for odd for this f of x would just be that when you input minus x into it, you're going to get back just minus f of x. So maybe let's just do this really quick and check it and see what happens. So if I check f of minus x here and we input, we'll have minus x cubed cosine minus x over 2 plus 1/2. And then here we're going to have 4 minus input minus x and square it. And now let's see what we have. So now here, because cosine is an even function, I can actually just make this minus sign go away, right? That is a plus. Then over here, we're squaring this. So you square minus x, you're just going to get back x squared. That's fine. And then here, this minus sign here, when we cube it, this x cubed is actually an odd function by itself. So that means I can just take this minus sign up front here like this. But then here's the trouble. This whole thing right here, this is actually not equal to minus f of x. It's really close. What we would need to happen here, we would need this to be a minus sign, right? Because then if that was a minus sign, then we could factor it out, and then we have, this is all f of x, then we have our minus f of x. But it's not quite working just because this 1/2, and so we need to do something else. And I think what I want to do is I want to distribute in this square root here and create this as two terms with two integrals. Okay, so now I have this broken up, and this is going to help us because now look what happened here. We could do the same thing and check it, but this right here, now this is an odd function. If you plug in a minus x, now the minus sign is going to go away on the cosine, and here, because this part is even, and then you plug in a minus x here, we're going to have a minus sign come out front. So because this whole integral now is odd, we can use this principle down here, and this first piece is just going away and it's going to be 0. But now here for the second integral, we can do something kind of similar because we have also this right here, 4 minus x squared. This is going to be an even function. Just noticing this is squared right there. And so we have a similar principle. We can just kind of redo this over here, and we can say if we have the integral for minus a to a of f of x, where f of x is now going to be even, then what we can do here, it's not quite as nice because we don't get 0, but we can pull a 2 out front and change the lower bound to 0, and so we're just integrating from 0 to a. So it's not much of a simplification, but it can help just a little bit. So what I'll do is use this to rewrite this. We'll bring a 2 out front, but 2 times 1/2 is just going to be a 1. So what's going to happen is we have the integral going from 0 to 2 of square root of 4 minus x squared dx. But now here, you may kind of recognize this. This is actually like the equation for a circle, kind of. The equation for a circle that we're most familiar with probably is like y squared plus x squared equals a squared. Actually, I think usually it's r squared because this is going to be the radius. And if we look at this, if we set this equal to y, and we say y equals square root 4 minus x squared, if you square both sides, we have y squared equals 4 minus x squared, and then we can write this as y squared plus x squared equals 4 or 2 squared. Now I did kind of cheat over here technically because when I square this, this should really be an absolute value. This really is always positive with the square root. So we don't really have the equation for a circle here. If we just look at some circle with, in this case, the radius is going to be 2, right? This is going to be like this point here is going to be at 2, 0. Well, first of all, here we're not interested in the negative part because our bounds go from 0 to 2. So we're really just looking at this right side of the circle. And then again, because square root's always positive, we're not going to have any of this part here. So really the area we're looking for with this integral from 0 to 2 is going to be just this first quadrant of this circle here. So in order to calculate this as an area, all we really need is the area of the first quadrant. Well, for the area of a circle, I can just use the formula a equals pi r squared, but in this case, we know our value is going to be just 2. So the area of the whole circle is going to be just 4 pi. But here we just have 1 quadrant, or 1/4 of this. So for my final solution, we just get pi. Okay, there you have it. Good problem. UK sample number 10. Thanks everyone for watching. Have a good day.